Hey everybody, welcome back to the channel. Today I'm going to discuss with you guys something unexpected about standard expected in C++. So before we get started, I'm going to hop over to CPP reference just so you guys can get a look. So standard expected, hopefully you guys all know about it. It's something that you can return from a function, so you can return an object or an error. That's the general use case for this. But if you come down here, you'll notice that even on CPP reference, they're just returning the double here, because that's what this expected function returns. It either returns a double or a parse error. They're just returning the double, or if it's an unexpected value like an error, it returns standard unexpected. Now, a couple things to note here. For one, this actually appears like standard unexpected as a function. It's not. It is an object that ties directly to an expected object. But to kind of give you guys a little demonstration here of expected, and the same also goes for variant and optional. I ran into this. I was using expected in one of my new code bases, and I realized that it was doing a lot of unnecessary moves. So I started looking into it, and maybe this would be addressed as compilers get better at understanding what expected actually is. But let's just hop right into the code and I'll kind of demonstrate exactly what's happening. Okay, so to start with, I have a lifetime object, and all this does is it's just a simple class that has a test, an integer, so you can get its value, and I'm kind of doing this to demonstrate what's being copied over and stuff. So, and also notice the single parameter lifetime is explicit. So this prevents implicit conversions, because this is what you should be doing in C++. So because we don't have implicit conversions, we can't just return 1 here. We have to return a lifetime of 1. So I have a couple functions. I have doExpectedNormal. So this is how CPP reference and a few other websites tell you to use the standard expected. And then I just return unexpected for the error case. And then we also have normal flipped, where the error is the thing that should be returned and the lifetime is the error, just so you can see what the actual result of unexpected is doing. And then I have the correctly and correctly flipped, and then void, because I noticed that there was not a lot of information on how do you return void. So what we'll do is we'll run the program first, and we'll go through section by section to see exactly what's going on. Alright, so the first one here, you'll notice that doExpectedNormal, hold on, I'm holding caps lock and I'm hoping that it's not going to register as a key. Okay, and it doesn't. So notice that doExpectedNormal here, it's creating an object with a value of 1, then it's moving that object, and then 2 destructors are called. So in reference, 2 objects are being created. Now this may be something that's unnecessary, but we'll go back and look at that function first. So doExpectedNormal is the way CPP reference and other websites are telling you to use expected. Now, while this is correct, there's an RVO issue here. The thing is compilers, and you can pop this in the Compiler Explorer and see for yourself on like GCC and Clang and stuff, but it will not optimize this. RVO breaks down here, and the same is true for optional and variant. But why? Well, it's because the function is supposed to return an expected of lifetime, but I'm not returning an expected of lifetime. I'm returning an actual lifetime. That then has to be moved into expected, because RVO is saying, hey, the most next efficient thing I can do is move, because you're not returning an actual expected object. And the same is true if I flip this with unexpected. So, okay, so what we'll do next is we will flip so that the unexpected value is the lifetime. Same thing. So we have this exact same thing playing out when you call standard unexpected too. So because unexpected again is not a function, it is its own object that then has its own copy of lifetime, and then that is being returned to the expected object. This is the way the RVO system is working. And by the way, this lifetime here in angle brackets, if I were to change this to passing it a lifetime here, RVO will not work. It will create 3 copies of lifetime depending on the compiler. So the and that at least on MSVC and I think GCC, Kling's a little better at it, but GCC and MSVC 100% will create 3 copies of lifetime. Yeah. So this, while is correct C++, I'm doing finger quotes here, we shouldn't be writing code that returns expected, optional, or variant in this manner. So we should actually be returning those types, and I'll kind of go into detail next. So we'll go ahead and go to the next one. Do expected correctly. Okay, now what do we get? We get 1 lifetime constructor, 1 lifetime destructor. So let's go down to that function and see what I did differently. So first, look at the do expected normal. All I'm doing is if there's an action, return a lifetime, otherwise return unexpected error, no action. When we go down to the correctly function, you'll notice that all I'm doing is simply, it's the exact same code, except now I'm relying more on implicit conversions. So I have this output here, which is just standard expected of lifetime, and the error type is error. If I return an output of 3, that's what's happening. It's creating this in place, okay? And it's not having to do unnecessary copies because I'm actually returning an actual expected object. The same is true, even though unexpected is its actual object. If I go to the flip, which would be the next one, notice that the flip is the exact same thing. So standard unexpected can be implicitly know what type you are creating the unexpected type for, as long as it's being passed into expected. So for instance, here I cannot do unexpected of lifetime and then pass 4. So what happens if I do that? Let's go ahead and see. Alright, so we're going to let this run. Oh, look at that. Now, that itself is because it's creating a unexpected value of lifetime, and then it's having to copy over. So the compiler can't optimize that away. But if we get rid of angle brackets lifetime, the compiler can figure out, because the only unexpected type that can fit inside an output is an unexpected lifetime. So, and it will do all the RVO that we're, in this case it wouldn't be RVO, but it'd be some sort of compiler optimization to get rid of unnecessary copy and moves. And just so you know, I'm not playing a trick on you. This is explicit, so it should not be doing this right out of the gate like it is, but it has no problem doing it. So again, this is one of the things where, like, even though it is an explicit constructor, because it's unexpected, it knows the type. You don't have to tell it the type, and everything just works correctly. Alright, so we'll bring this back. Okay, so now you see that there's no unnecessary copy or moves. It's just working correctly. Now, another thing that I could not find on the internet, but is kind of a common use case for this, maybe I want to return an expected of void and then an error if an error occurs. Now, you may be asking, why would you do this? Because there's either a true or false state. Well, it's not that simple, because what if you could return, and you don't want to return an error code, right? You don't want the user to have to handle error codes if there's no error. So why even check for an error? Now, you could wrap this in like a struct type or something like that, but the standard already gives you a way to handle this. Expected void with the error type. So the way that you do this is the exact same thing. You create an output declaration and you return an output that's empty, like this here. This solves all of your problems and it returns void essentially. And then we need to return an output of unexpected, return output of standard unexpected, error, no action. And then if we come down here, you can check if it actually has a result. Now this is what's weird, but a void result is simply a result that has nothing in it. So if the type is void, then it's going to, the bool check, the explicit operator bool, will actually return true if it's in a valid state. It will only return false if there is an error attached. So I did that here, an error of void result, and I just pass in false to do action. It should throw an unexpected error. And then here I just print that out. So we'll see what that is. All right, void result. So that means that void result happened because we returned an empty output. So that means that that was correct. So that means that, yay, we're good to go. But the other one is, hey, there's an error. So I need to print that error out. And all I did here was take the error, because it's an enum class, the first value is 0. So it's printing out error and then 0. So the same thing applies with optional, variant, and expected and unexpected. These 4 types, you need to return those types from the function, not their encapsulated members. So I just wanted to make this quick video because I ran into this issue and it was creating expected results because there was just a bunch of unnecessary moves and stuff. Eventually, compilers may be good enough with RVO to completely cancel out this problem. And by the way, I'm not just running this on some random build. I have optimizations all the way up. So just to kind of give you some references here. I mean, here, I'll prove it. Optimizations OX. This is the fastest for Visual Studio. But even if I were to put on Oath 2 and then run it, what do you think happens? Let's say for the first normal one. And then I've also had, well, maybe it's because I'm in debug. So let's switch it to release mode then. Oh, I'd have to, hold on, bear with me. Set up the compiler to work. And what do you know? Same thing. Fully optimized, RVO is not going to save you here. That's why it's important to have this using declaration. So I just wanted to kind of show you guys this to make sure that you're using expected and unexpected and optional and stuff like that correctly. And also notice that when I'm returning an unexpected, the correct way to do that is to wrap unexpected inside of output. I don't know if I made that clear before, but that is the way you need to be doing it. And stop calling unexpected like a function, because it's not a function. I love like function calls. And I love the fact that objects, when they're being constructed, you can use these little squirrely braces here. Because to me, if I'm reading code and if I see parentheses or regular like call braces, I'm going to assume that it's a function. And CPP reference did this. See right there how it's doing that. Now, there's a couple of things. The first thing is you'll actually get a compiler, I think either an error or a warning. I think it depends on your level, but you'll get some sort of notification that, hey, you're passing an int to a function that requires a size t. First off, they're the wrong size, and there's an unsigned signed mismatch. So what are you going to do about it? And the compiler just lets you know that that's an issue. And with this, there's not technically an issue. And it also helps the compiler with return value optimization if the actual types can be known. I have not run into a compiler where if you're using this as a function that it doesn't do the optimization for you like this, but it doesn't matter. I still think you should be using these curly braces to represent object construction or initialization. If it's a standard int, use the equal sign. I do please stop calling constructors with parentheses because it confuses, especially new developers. When they're coming to the scene, they're being taught to do this, to direct initialize using the braces or with an equal sign. If the first thing is an equal sign, you're good to go too. So at least in most compilers. So yeah, I just wanted to give you guys a heads up on that. This is annoying. I hope that they do fix this, but this is still valid. I mean, this is an extra line of code. Like, it's not that difficult. So all of my code from now on will be doing this. So anytime there is an expected, an optional, or a variant, I will actually have this as the first line of code in the function, using output and then the type. And now I can wrap output into that. And again, stood optional, stood variant, and stood expected. Please, please, please wrap these up correctly. Return the actual object, not the lifetime in this case, but I'm returning an actual expected object, and allow RVO to work correctly. All right, anyway, you guys have a good day. That's all I needed to share. You can go to my GitHub. Link will be in the description. I'm working on a generic C++ library that can be used in many different application domains. Do not use it in production code because a lot of the stuff is going to change. It's not even close to ready yet, but it will be ready within the next 6 months to a year. And I'm also going to be pumping out more videos on how to use that library and the remote desk app. I have not forgotten about it. It's just been really long. I've been working really long hours, a lot of odd jobs here and there, so I just don't have a lot of time. Anyway, y'all have a good day. Peace.